Imagine this. You're hurtling through space at 299 kilometers per second, the speed of light. But what if you tried to push just a little faster? Your body, your very reality, would shatter into impossibility. And what Richard Feynman uncovered about why. It doesn't just bend your mind, it collapses it entirely. Welcome to Physics That Hurts, where we dive into the truths that sting the soul. In the minutes ahead, I'll reveal secrets of the universe that Feynman himself wrestled with, secrets that make you question if time, space, and even your existence are illusions. If you walk away now, you'll miss the key that unlocks why. Nothing, absolutely nothing, can outrun light, and what that means for humanity's wildest dreams. If this is your first time here, hit that subscribe button right now, because once you see how deep this rabbit hole goes, you'll want every video that pulls you in further before the universe pulls back. Picture yourself in a quiet room, late at night, staring at a flickering candle. That tiny flame? It's not just fire, it's a messenger from the stars. Light, the fastest thing in the cosmos, racing toward your eyes at a speed so constant, so unyielding that it defies every intuition you have. But why? Why can't we go faster? Feynman, that mischievous genius with the bongo drums and the Brooklyn accent, didn't just explain it, he unveiled it like a forbidden scroll. Rewind to the 19th century. James Clerk Maxwell, a Scottish wizard of equations, is scribbling away in his study. He's piecing together the puzzle of electricity and magnetism, and out pops this number, 299,792 kilometers per second, the speed at which electromagnetic waves, like light, travel through empty space. No matter how you tweak the math, it's always the same, constant, unbreakable. But here's the shiver down your spine. Maxwell didn't know he was staring at the universe's speed limit. He thought it was just a quirk of waves. Enter Albert Einstein, that wild-haired dreamer, who in 1905 drops his theory of special relativity like a cosmic bomb. Einstein says, what if light's speed isn't just fast? It's the law. He postulates, the speed of light is the same for everyone, everywhere, no matter how fast you're moving. Sounds simple, right? But Feynman later showed us, it's anything but. Imagine you're in a speeding train, tossing a ball forward. And to you it's slow. To someone on the platform, it's blazing. That's how speed works in our everyday world. Relative. But light. Fire a laser from that train and its speed doesn't add up. It's always c, 299,792 kilometers. No more, no less. Why? Because if it weren't, time itself would unravel. Feynman, in his lectures that feel like campfire stories from another dimension, breaks it down. He says, think of space and time not as separate stages, but as a single fabric, space-time. Moving through space steals from your movement through time. The faster you go, the slower time ticks for you. It's not magic, it's math. But push toward light speed and something horrifying happens. Your mass, it swells. Infinite. The energy needed to accelerate, bottomless. Feynman uncovered this in his quantum electrodynamics work, QED, where particles dance with light in ways that enforce this limit. Try to cheat it and the universe says no. But what if you could? What forbidden door would swing open? You're an astronaut, strapped into a ship that's somehow, impossibly, nudging past sea. Stars streak by like fireflies in a storm. But glance back at Earth, and time warps. Years pass there in your seconds. Your family ages. Civilizations rise and fall while you sip your coffee. That's time dilation, Feynman's playground. He loved teasing this. If you go fast enough, you could return home to find your great-grandchildren waiting, but you'd be the same age. We've seen this. Muons, tiny particles born in cosmic ray. Showers should decay before hitting Earth. But they don't. Why? They're screaming down at near-light speed, so their clocks slow. They live longer from our view. Feynman points out, this isn't theory. It's happening right now above your head. Crank it up! What if you hit light speed exactly? For a photon, a particle of light, time stops. From its perspective, the entire universe flashes by in an instant. Birth to death of stars, simultaneous. Feynman whispers this in his books. Light doesn't experience time. It's eternal in a way. Mind-bending, isn't it? You're made of stuff that plods through seconds, but light? It surfs infinity. Yet here's the mystery deepening. Why this speed? Why not slower, faster? Feynman dove into quantum fields, where virtual particles flicker in and out of existence. Light's speed emerges from how these fields interact, the permittivity and permeability of vacuum itself. Change them and the universe collapses. It's like the cosmos tuned a dial to exactly this number for us to exist. But Feynman uncovered something darker. In QED, he shows light doesn't take a straight path. It explores every possible route, zigzagging, looping through space-time, and the paths interfere, canceling out until only the fastest survives. The straight line? An illusion of probabilities. Your reality? A sum of infinite ghost paths that light discards. Visualize this. You're walking through a foggy forest at dusk, flashlight in hand. The beam seems direct, but Feynman says no. It's every wild detour, whispering secrets, then collapsing into what you see. In experiments like the double slit, light behaves as if it knows the future. It interferes with itself, choosing paths based on what's ahead. How? Feynman admits, I cannot explain it in a way that's satisfying. It's nature's riddle mocking us. And the emotional gut punch. This limit isn't a barrier, it's a guardian. Go faster than light, and causality crumbles. Effect before cause. You could send messages to the past. Kill your grandfather before you're born. Paradox. The universe forbids it. Feynman argues because reality would dissolve into nonsense. Your choices, your loves, your regrets, all tied to this speed. But what if that's not the whole story? Feynman toyed with tachyons, hypothetical particles born faster than light. They'd move backward in time. In his mind, they're ghosts, unstable, unraveling equations. Yet experiments hunt them. Nothing. The limit holds. Why? Because breaching it would rewrite physics. No atoms, no stars, no you. Think of your morning jog. You're pushing limits, heart-pounding, muscles screaming. But light, it's the ultimate athlete, effortless. Feynman, who cracked safes at Los Alamos for fun, saw the universe as a grand safe. The combination? This speed. Crack it wrong and boom, nothingness. But Feynman found a crack. In the quantum foam. What if light isn't the fastest after all? Dive deeper. In the quantum vacuum, particles pop like bubbles in soda. Feynman diagrams map their chaos. Electrons emitting photons, absorbing them, looping in time. And here's the mind collapse. Some loops allow faster-than-light influences, but they cancel out. Perfectly. The speed limit enforces itself through infinity minus infinity math. Feynman called it sweeping infinities under the rug. Dangerous. Yes, but it works. Real-life example. GPS on your phone. Satellites zip at 14,000 km/h. Without relativity. Without accounting for their slowed clocks and warp to space, your maps would drift 10 kilometers a day. Feynman's insights power that. The universe's forbidden knowledge in your pocket. Philosophically, this hurts. If light speed caps everything, are we prisoners? Feynman pondered, the universe is absurd. Time flows one way because of this limit. Entropy, the arrow of time, ties to it. Without C, no past, no future, just eternal now. Like a photon's existence. In black holes, light bends, trapped. But Feynman's QED hints at Hawking. Radiation, particles tunneling out faster than allowed? No, it's quantum trickery. The limit bends but never breaks. You're on a beach at sunset, waves crashing. Light from the sun? It took 8 minutes to reach you. But if you could ride that beam, the journey? Instant. Feynman says, perspective shifts everything. Your reality, just one frame in an infinite movie. What about wormholes? Einstein-Rosen bridges, shortcuts through space-time. Feynman explored them in quantum gravity attempts. Travel through one and you might emerge before you left, faster than light, effectively. But stable ones require exotic matter, negative energy, that violates rules. The universe slams the door. Feynman uncovered this. The speed of light isn't arbitrary. It's woven into the fabric. From Planck's constant to gravity's pull, it balances existence. Too slow? Stars collapse prematurely. Too fast? Atoms fly apart. It's Goldilocks, just right for life. Coincidence or design? In a world racing faster, texts, planes, thoughts, light reminds us of humility. We chase infinity, but the cosmos says, enough. Feynman, battling cancer in his final days, stared at this limit. I'd hate to die twice, he quipped. It's so boring. Even in death, he danced with the eternal. Now your mind is just beginning to fracture. One question to leave your brain uncomfortable. If light speed is the limit because the universe protects causality, what terrifying truth is it hiding from us about the nature of free will? If that question haunts you like it does me, subscribe now. Join the thousands uncovering these mind-collapsing truths on physics. That hurts before the next revelation shatters what's left. Because in the end, the speed of light isn't just a number. It's the veil between what is and what could never be.